We are back live. Stupid timeline. Let's look at carbs. So yeah, right. The thing that we were doing last time, we got this data, right? So what we're gonna do is test GP. Okay. Data. Hold on. Success observations. These need to get mapped to score and cost. Oh wait. Yeah, they are there. Okay. Output, real number input. Okay, so we just do cost. Torch.tensor. From numpy. E dot cost for E score. And then we do obs stack real number for in data. Okay, now we have this here, and let's go look at a Gaussian process. GP regression. Pyro. Look at all this junk. Heck is this jitter? GP so this is inputs, which is obs. Outputs, score. Kernel. kernel get model return. Okay, so we want this. Input dim. Params length scale. Is 1. Okay. Um, wait, nope. Success. I don't think we need this. NumPy. Okay, so now we have our model. Now how do we run it on the data? Get kernel, surrogate to target. Fit suggestions. Get model. Oh, is it just a board pass? Yeah, it is. What in the hell? Where the hell do they call the model? Give Pareto surrogate. I think you just call the damn thing. Yeah, you do. And this is going to be values and variances, I believe. GP regression. Let's check. Forward. Returns. And variance. I assume that's mean and variance. Okay, so this fits, right? Look at this, tiny errors. Time steps. And what are the parameters here? So it's learned to completely ignore that variable, right? Yep, doesn't care. This one it probably cares. That's 3. Oh, nope, one more. Though I'm a little concerned I don't know which one's the learning rate. Uh, Excuse me. What the hell? Oh, I see. Yep, that's fine. It's 2 rows. I didn't realize. The heck? Really? What the heck was I doing before? Model. No, there's no coin. And there will be no coins. The heck am I doing here? Thanks, love your... Yeah, no problem, man. I didn't mean to be rude. It's just I get, like... I get crazy crypto folks in here all day asking me because some asshole stole my brand and launched some like rug pull coin. It's silly. I'm currently working on hyperparam sweep stuff, trying to get a better hyperparam sweep algorithm, but the base code I'm working off of is really not very good, and there's some weird stuff going on. So I'm currently trying to figure out if their Gaussian process is just messed up, or if there's something fundamentally wrong with what they're doing. Clone. Yeah, this doesn't make sense to me how this is. How's this like this? Now the error is there. Is that not actually copying? You know, wait, yeah, it's gonna be really cool when it's done. But I mean, the repo is nearly 2,000 lines of nonsense. Should be like 500 at most. And I can't tell if they have errors in there or if there's something weird, but basically at the moment what's happening is they've got all these Gaussian processes and they're way underperforming what they should be. So like anything that you build on top of them doesn't work because the core predictions coming out of them are not working well enough. They're directionally correct, but they're just very poor. This is bizarro. Am I doing something stupid? Wait, clone. Diff. Obs.clone. Clone do what I think it does? If I set this in place, what in the heck? Is it like caching? That's freaking so dumb. It is caching it. Is that a torch thing? What in the heck? You change it in place and it freaking caches. Holy hell. That's like so stupid. Okay, so all of these have quite a bit of error on them. The two big ones I imagine are probably the two parameters we care about. I mean, isn't it literally like They're doing linear regression with SGD. That's so stupid. Um, what's the freaking formula? It's like pseudo inverse or whatever. So we should just be able to do obs times weights. The hell? Why are these people overcomplicating the hell out of it? It's super easy. There it is. Does Torch have PNV? Yep. Something is screwy here. Something is very screwy here. Okay. Args a sweep. And I would assume these are maintained in the same order. Okay, so this makes sense. This is total time steps, right? These other ones don't make sense at all. Okay, so it's not just the Gaussian process, it looks like something's wrong with the data. Because a linear fit should not produce this. And I think that this corresponds to the errors as well, right? Highest error, highest. Oh, it doesn't. Yes, it does, because this is 0, 1, low, low, higher, higher, low, low. Yeah, okay. So this seems to correspond. So it looks to me like the Gaussian process and the linear like function are learning. But the data seems wrong. So why is the data wrong? Suggestion in param. Suggest output. To param space. Observation in basic. Basic. Wonder if this returns them in the wrong order. I still don't think that would do. Would this do that? I'm trying to think how I can check on this. Wait. Huh? What the hell is this? Oh, this is just my clipping. But it doesn't get applied. Yeah, this doesn't do anything. I think this was just checks. Basic from param. Real number space by name. Do you think copyright concerns will be an issue? So, making a big kerfuffle about copyright for AI training is probably the single stupidest thing you could possibly do. That is like a great way to completely cripple all of your AI stuff instantly. Um, that should just be thrown out. Should just be thrown out completely. You think they care about copyright in China? They don't give a shit. You're just putting yourself at a massive, massive disadvantage. I mean, Japan has just straight up said, like, haha, copyright doesn't matter for LLM training. That is the correct thing to do. Mm-hmm. I mean, just think about it, right? Like, this is one of the contributing factors for sure. I mean, definitely not the only one, but it's a contributing factor to why China's able to come out of left field and just drop a model like that. We have stupid laws. Like, oh yeah, we're too open AI for like using New York Times stuff, and you gotta license this data and license that data. Like, piss off. You're literally doing nothing but harming progress in AI. Europe is, as far as tech goes, Europe is a backwater. Nothing is coming out of Europe anytime soon until they fix their broken legal system. Mistral's pretty cool. I have no idea how they do anything with the laws over there. They're probably just scraping stuff and hoping they don't get caught, frankly. Okay, so this is in the same order. Rights holders have. Yeah, but they're just gonna get steamrolled by economic interests. I mean, I sympathize with the artists in the sense that we got some really stupid tech bros that seem to go out of their way to piss off artists and go, ha ha, look, we don't need artists now. We can just generate stuff. You're useless, ha ha. It's like, no, you dumb tech bros, right? But on the other hand, it's like, no, you also can't hold all of U.S. tech progress hostage because my copyrights. Mistral's over. They're still releasing models. Didn't they just release a model? They'll probably get acquired or something. Or they'll decide to make all the models for Europe and actually abide by all the crazy laws there. I don't know. They'll do something. Okay, so we do have this. That's so weird. Basic from param. Is it like decoding wrong? Man. Ooh, that looks bad. They don't care that much. Yeah, I mean, they're just being ridiculous. Oh wait, I'm stupid. So this is dim. Okay. Researcher. Yeah, I saw there was some stupid bill. They're just gonna get smacked for that. That's not happening. There was another bill that was like 20 years in prison for downloading deep seek weights or something. They're just gonna like this shit doesn't pass. Like they've got too many tech people involved now in government for shit like that to pass, you would hope, right? Like Elon or somebody is gonna look at that and go, "What? What idiot wrote this? Stop it!" Right? Okay, so this is not the problem. The encode to the decode works just fine. It's very weird. What China Hawk comes up with. I, there's senators in their 80s that have no idea what they're doing. One is the one that we're running right now. Linear. Total time steps. Learning rate. Just these two, right? So y but open source here is good. Putting the US behind China is just incredibly stupid. All that bill does is put the US behind China. Well, the DeepSeek one. I don't know about the collaboration one. The third highest weight is there. How does it get all these other spurious parameters, though? What the heck? Open source one. Is it the same? I saw like a one-page bill. AI for Tesla. No, because he has all of XAI now, right? I would like to know why this is happening. Is it just getting spurious correlation because it doesn't have enough unique sample points or something? Guess that would make sense. But why are none of the weights near 0? 0.14, I guess, and 0.04. Which of these are... Wait, and num, time steps, batch size, mini batches. That's crazy for the learning rate. Entropy, lambda. Yeah, that doesn't make any damn sense. I guess I have to get other data, don't I? Can I just like... You know what? I know what I can do. I know what I can do. Not this one. This should be 50. So I'm gonna see what happens if I get random samples. If I fit those, and the model is still bad, then it is a biased data problem from the online sampling procedure. Wait a second, what the heck? This shouldn't take this long. It's doing something stupid here. What is it fitting a model for? What the hell is it doing? Hello? Do I not pass this? What the hell's wrong with this? Ah. Kind of ridiculous. Oops, I did. Did I do torch save? I did. That's okay. I can modify this. How does it still come up with this mess? Like what? Is this a good fit? I mean, it's probably a good fit as well. It's wild. Like, the errors are way lower than before. For some reason, update epochs, I guess that gets sparsely sampled. But everything else, the errors are way lower than before. So there probably is a sampling bias screw up. Yeah. Well, but the scores are lower as well. Yeah, you see. Why is it that bad? Is my intuition just totally shot now these days? Like, this is a regression problem with one target variable, two relevant input variables, and some distractor variables. No Diet Coke for me, thank you. Ugh. Okay, since this isn't working, we're gonna try one last thing on this. Oh, dot pouch. That's funny as hell. We've just decided to optimize against 0. Okay. Yeah, that doesn't make any sense at all. But that is a fit. You get the same parameters consistently. Oh no, you get totally different stuff. Shouldn't be able to overfit. It's a freaking line. Hmm. I can't figure this out. I can't figure out why you can't fit a model to this data. Um, is it like data transform shenanigans? Okay. Scores, costs, hypers. We will figure this out. Scores. Got list. Cool. That's normalization required. And we're just going to do obs max dim equals. Okay, very nice. And still, one point oh, 1.0. What the hell? How the hell's that happen? Wrong dim. Okay. How is this still not clicking? It's random data. Pushes everything down. That's weird. I don't understand how it is that I'm failing to fit a line. With 3 different methods. Like, shouldn't take that many points, right? Well, not liking this. I'm actually trying to think what the hell is wrong here, and I can't, like... Okay, you know what? Moron test time. Super moron test time. Okay, so that's what I thought. That's what's supposed to happen. Is you generate data. I guess I have 50 points only. It'll still get it with 50 points. Heck, it should get it with 10 points. Doesn't actually get it with 10 points, interestingly enough. 30? Ooh, okay, hold on, that's interesting. It gets it with 50. Wait, does it? 0, 1, 2, 3, yeah. 0, 1, 2, 3. Oh, it starts to get it, I see. Yeah, it's 10x, okay. So, and by 50 points, it's got it. Tell me that was it. Why doesn't it know this one? Learning rate. I guess this is not a linear function. The learning rate isn't. The cost is, but wait, it's not negative, right? Shouldn't be negative. Oh, no, it didn't get it at all. That's so weird. I did 5,000 points as well, didn't I? Oh, no, I apparently didn't before. What did I do? $5,000. And data. Work, and then I did it again. Well, no, because we still have extraneous variables. So it just came up with a different bad solution. Maybe it's figured out some of these, though. I mean, this looks better. Let's see which ones it hasn't figured out. GAE lambda, I guess. 1, 2. I don't know why that one would be hard. Gamma entropy. Learning rate shouldn't be negative. Isn't this still a bad model? Hang on. That's still a bad model, isn't it? Wait. I swear. Oh my god, you idiot. Oh, how do you fuck that up? There you go. Way closer. Did it just fail? Oh no, it just didn't optimize all the way, it looks like. 04, kind of funny it gets that. Uh, there you go. So that's what we were looking for. Yep, you did the same thing here. I don't know how I fucked that up. Hmm. Okay, and m's total times this, what the hell? 1, 2, 3, 4. Okay, so we get learning rate here. There are a couple spurious ones. This with friggin' 5,000 points, though. Love this project. Great to see it come together. Thank you. I'm currently fighting weird things. Very weird things. Hyperparam optimization is going to work. Honestly, the only problem I'm having right now is I'm trying to figure out what the heck is wrong with they're just like these tiny little models that need to fit hyperparams, that just need to like predict from a small data set of experiments what hyperparams are going to do, and for some reason it's being weird. It's like substantially different from run to run. No, wait, what? Yeah, okay, so this is nuts. Oh no, this is the same. So for whatever reason, though, it's not picking up total time steps as a variable. This should be very weird, right? What one did I have? Test. Hold on, maybe I did the wrong data. It's possible. If so, I think I'm going to take a break tomorrow because I should not be making these mistakes. Yeah, see, this is just me being like, that's such a stupid mistake to get hung up on. Jesus. Yep, and immediately there we go. So we have, it's a little weird that we get like these spurious coefficients still on here. It's a little weird. Okay, yeah, it's literally, it's just optimizer. Cool. So now you only get 50 points. And this is fit. This spurious one is very weird. Oh, I guess it biases off with this. Can I disable the bias? It's really weird how they still do this. What's the plan? I'm currently attempting to improve this hyperparam sweep algorithm, but I'm having a bit of trouble. What essentially set all this mess off that I'm dealing with at the moment is the Gaussian processes that are trained online to estimate the score of any given like query set of hyperparameters. These are very important. They were very inaccurate. And basically anything you do on top of them is going to be very limited by the accuracy of that little model. And it should be able to be pretty good. So I was trying to figure out what was wrong. Nine eighths as low as it goes, huh? Well, at least now we get the strong cost effect in there. And we get zero. Wait, 1, 2, 3, 4, 5. Yeah, we get the learning rate param in here. And then there's some spurious stuff over here. The spurious ones are, for some reason, gamma and lambda. You know what I bet that is? I bet they just offset each other because they're pretty close to constant. I bet that's probably all it is. What if I just add a little weight decay now? Is this actually, will this fix it? Hmm. Nah, that's just crushing the model. Though it is actually fixing the, this is the highest you get away with. Better than nothing. Okay, so can we at least recover this from the Gaussian process? Let's see. What's our Gaussian process going to give us? I'll tell you what, let's do linear error. 0.6. And then let's do this now. Come on. Okay, so I mean, if this is comparable, it fits the train set way better, and then this parameter, these two are the important ones that we care about, and then these are the spurious ones. Which again, I think probably because they're so close to constants, that's probably what's messing it up. That would make sense. Which is why the data transforms are important. What's a quick transform to unit normal? Subtract oh. Duh. Okay. I'm definitely getting tired. Subtract the mean and divide by the standard deviation. Okay, so the Gaussian process error went way down, and the spurious correlations went down as well. This did not go down. Let me see. Linear error went up. Oh yeah, because it's transformed into normal space, obviously, so it's no longer a linear fit. So that's why I couldn't fit a linear to the data before, obviously, because it was transformed into that space. But the Gaussian is perfectly fine, and this actually fixes it. Cool. Very nice. So cool. I now understand roughly how to make these things work. This is with 50 points. It's a little disappointing that there's still so much weight on this, though. Mm-hmm. Worse, yeah. Interestingly, still worse. Yeah, they're right. This is the best kernel. Hmm. Mm-hmm. It's weird that there's so much substantial error. How much does more data help? I mean, it helps a bit. Still have a lot of error. Hmm. Their parameter here. Way worse. I'm just playing around to see if I happen on anything. I think that's worse for 500 points, right? So 2 and 0.2. There are some tuning things. There is some tuning that can be done there. Still a lot of error. Well, hang on. It's a lot of error if you delete a parameter from the set. That's not a good measure. It fits perfectly. I'm trying to think if I want to just start rewriting the code base, because the original is just such a mess. It's like impossible to figure anything out like this. I think I could pretty easily do it in a small fraction of the original length. Probably make it a lot easier to reason about. But there are a lot of little details to be careful with. I am really sick of dealing with this code, though. Let me think. Yeah. Okay, here's what I'm gonna do. For folks on YouTube, here's the current situation. I've got what I think should be some very major improvements to this algorithm. The original doesn't make mathematical sense in a ton of different ways. They got very good results regardless, but there were definitely places for improvement. I made some modifications and got some initial results, including on a bunch of real RL environments that are very promising. But there's still a lot more that can be done, and there's still some edge cases. This morning, I got very compelling evidence of these edge cases and of places where my new and improved algorithm still does not work. I did this by running it on synthetic benchmarks, where the outcome is known and the task should be easy, and any sane algorithm should be able to do it. Doesn't mean that most of them do, but they should be able to solve it. Then I started trying to modify the original code base to include my changes, which was very easy, but I ran into some difficulties because the code is just really noisy. You kind of rely on having a good estimate of the Gaussian process. It has to be a good estimate for you to really get anything, and that wasn't really happening. Now, on one hand, it is the case that you kind of have the same Gaussian process before and after, so I could probably continue editing on it a bit. And maybe I should, I don't know. It's like I really want to just start rewriting it, but it still might be a little bit early. Maybe we run a few more tests first, knowing that this is an issue. So even this simple test should not yield perfect performance, right? Let me maybe do that first, and then we'll try rewriting. You know what we can do that will make it a little easier? Let's seed it with let's seed it with 50 random samples. That should make it a little easier for the algorithm, and this should run instantly. Synthetic linear. So we'll cheat some random samples in, and we'll assume that we'll be able to get the random samples reduced, requirement reduced just by improving the GP. I think that's reasonable. Data path is going to be so 100 runs, which is 50 carb samples. Okay, so here's our current function. This is the full version of our function. Oh, also I've had this run going in the background the whole time. So you can actually see even the current version where we've gotten our results. Looks like still around 91% is the best. 91 on this task. Oh yeah, this will be a very nice algorithm. If we can improve over this even more, holy, it'll be great. And I think that this is one of the most important things you can do in RL right now. I really do. Having consistent hyperparam sweeps that you can trust, very important. This was an earlier test. The shape of this is decent, but it needs to go explore further out in cost quicker than this. So what we're doing right now is just because I know that the Gaussian processes are a little wonky, we're just spotting it a little bit of training data in this region right here for the most part. It might occasionally sample a way out there point, but we're spotting it a little bit of training data, and hopefully we can get something out of that. This one seems to be very conservative. And we will load this up in a second once it finishes running. It's pretty quick. Amusingly, I sped their algorithm up like by a factor of 5 by taking it off of the GPU because they were training a tiny little model on a GPU. Okay, so here is currently what we've got. Like I said, the blue points down here, we spotted it some data. These are randomly sampled, including this one and even this random one out here. So we don't blame these points at all. The only thing that we're concerned about here is the fact that this takes so long to fit this line. This is 50 points. And we should be fitting way farther out there. So let's look at what we have here. The first thing that we are going to look at is commenting the cost in this new version. So this no longer penalizes you for running long experiments. And then if this does not do it for us, then we will we'll rethink a bit. Because right now we have GPYX, which is the model's prediction of our performance. We subtract Y nearest, which is the nearest Pareto point that is a faster experiment than what we currently have. So you're taking the difference in performance between the next fastest run that you have and this sample, and then you divide by the cost of the sample. You would think that this would actually... Oh, you know what? When you divide by the cost like that, I think you have to already have dealt with, you have to have already normalized the target estimates, right? Yeah, okay. So I got sidetracked with a lot of stuff, but I was going to do some normalization on the top term. Because right now it's just whatever score comes out of the environment. So, yeah, there's not much incentive based on the slope of this thing, right? This is just like a slope of 1. So if you double the cost, you double the performance, but you get charged twice as much. So there's really not much incentive to explore. Because let me see. Well, no, because you still are incentivized to fill out the Pareto front, I think. You should still be incentivized to fill out the Pareto front. It doesn't look like that's what's happened, though. Here, we're gonna take this one and we're gonna put it here. So it's a little bit less conservative, and it makes a few more errors. We're not too concerned with these, but really barely. So why is that? This should be pushing you towards higher cost like mad. Target estimate. Hey, welcome. This should be pushing you to higher cost like really fast. GPY8x minus y nearest. Well, we don't need the ReLU right here. We don't need the ReLU right here. I don't know why that would matter. We don't need the ReLU there. It'll be interesting if it does matter, though. Because that will also tell us something. Let's play around with this. It is possible technically that I've messed something up in this code, if anybody sees anything. So this is our estimate. This is our Pareto optimal cost, or the cost of our Pareto optimal points. Wait, what? No, GPCX, yes, okay. This is the cost estimate. This is the Pareto cost. Anything that is more expensive than our current estimated point is not going to get sampled. We're going to take a min. We find the index of this cost difference. Then we get the Pareto index, and we use that as y nearest. Okay, this ReLU does not seem to matter, which is what we would expect. I can just tell looking at these numbers that this isn't going to help. Here's the simplest possible term. Instantly jumps to the high end cost. So it knows. Look at that. Okay, so when I remove this baseline term, it instantly jumps up to the top. So I think that there's something might be wrong in this calc, because it should not make a difference like that. Okay, so here are your Pareto costs. And here's your GPCX. GPCX. Okay. Cost difference. This is like 0.7, which is correct, and then 0.7, 0.4. So these look good. So then let me see, for 1.7, it's probably going to be, wait, 0, 7. Closest Curry 6. Well, that's fine because these are equivalent. And then what was it? 25 for this high one. Yeah, it's going to be all the way at the end. 0.8 is 0. That's a little bit of a quirk. But 0.8 is 0, yeah. Hey, these Pareto indices look fine to me. So $101, right? Well, duh. OSS 85. Wait, let me see this. So Pareto costs GPYX, GPCX, 1.7, goes to here, which is 1.49. How's this happen? Oh wait, no, it's the other one. Yeah, 1.49, okay. And this is 10.8, 10.18, which, yeah, probably did this. Okay. So GPC X. And this only predicts 7. Okay, so this estimate's just wrong. It has no capability at all to predict score, it seems. Or maybe not to predict cost. Because this difference is right, this formula looks good. I guess this is the issue when you have two estimates. It's directionally correct, but then you take two of them, you put them together as a ratio. It underestimates very severely. Target estimate. If you take GPYX, the thing is, the cost estimate ends up being right, or more right. So if you divide by it, you're screwed. Man. I mean, this is tough. I have the right formula here, but it's like, we're just getting screwed by the inaccuracy of the Gaussian process. Which must be why our previous formula worked so well, because it just biases you towards absolute performance and to kind of to screw everything else. How do you solve that? You got y nearest. It's very weird. Those things aren't bothering us. I mean, okay. Let's say that I use my full formula. When referencing the M's in Puffer and assume code, not really. There are a couple contributor M's that were before people were before like I had the opportunity to do a bunch of code reviews. So if you start seeing like double or triple pointers or shenanigans or stuff that looks weird and redundant, it probably is. The M's that I have personally written at this point are MOBA, Neural MMO, Snake, and then the new grid that's in ablations. Some of Spencer's recent stuff is pretty darn good. Captain's Physics M is so far pretty good. Noah's TCG stuff has been mostly pretty good as well. His additions to that. I think that the current code in there, just TCG and RoboCode, I don't think we've merged them yet. So I think both of those are my prototypes as well. Anything that's currently on my screen here is not well-written code. Hang on, have I been stupid? No, I think actually... No, I've been good. This is smart. This is the way to go. There's the expected improvement formula. Do I need that? So weird. Mm. This is towards higher variance. Don't want to bias towards higher variance. It's annoying because the only reason that it's staying in that zone is that the model sucks, right? Maybe it is legitimately time to rewrite a big chunk of this code because, like, I'm looking at this. This formula looks good to me. This looks like this should work. I mean, what you want is for this to be a little sparser, right? Okay. Oh, there's no. Oh, there is a breakpoint. I'm done. Burrito scores is correct. I could do quantile or my percentile transform. I could do that now. Int star. Nope. I do the first one. So what you do is you go and you go into a bar with a bunch of programmers and you ask that question and then they all shoot each other. Oops, fuck. I closed the wrong window. I've had that all day. Well, I think that was mostly converged anyways, but fuck. so this is what we have. There's really not that much to be gained. We took cost out and it didn't even help. That's the weird thing. So weird. Why nearest? I don't think I've tried this yet. I want to see if it's really just the baseline that's somehow screwing it up. I don't think I've tried this. No, use the damn arrow. Don't do star thing, just use the arrow. It exists. It exists for that reason. It's 3 characters all split up versus 2 characters grouped. In the same place you'd expect a dot to be. So yes, use the arrow. You can see that the cost predictions are actually like mostly kind of reasonable. And the score predictions just suck. Nope. No AI editors for me, thank you. I use Super Maven for mostly single line complete. That is what I want. Okay, so interestingly, just this core term is also enough to screw this up. It's also enough to screw this up. Though I think that that one is more acceptable. Let's add, let me add something. So Let me screw up GPT. Oh, I do pay for Super Maven. I mean, it's stupid not to pay for tools that improve your productivity if you can afford them. I'm gonna do this instead. Average, what the hell? All these functions suck. Yeah. I honestly prefer Python's white space and lack of curly braces. I honestly do. Okay, good. Interesting. Maybe rank transform is all you need. I wonder what happens just with this. Oh, well, that's gonna be too much. Fuck. I mean, if you divide the entire thing. Yeah. Okay. I don't think this is gonna do anything on its own. What the hell breakpoint did I forget? This one? Go away. I don't think the rank transform on both of these makes any sense anymore, actually. we just mess everything up with that? Don't know how that happened. I'm getting pretty tired here though. Gonna have to break for dinner in a minute. All right, I got some stuff that I gotta think about with this. I'm pretty tired for the time being. I'm gonna go get some food, do some stuff, and we will see from there. For folks tuning in, it's some days you get like ridiculous progress all at once. Some days things go a little slower. I think there is something here. It's just going to take a while to get it right. And we're definitely going to have to rewrite a lot of that code. But if you're interested in the work and following all this stuff, it's all free. It's all open source. The only thing we sell are service packages for companies trying to do RL a little bit better. You can check out the code right here. Star the repo really helps us out if you star the repo. It's all on puffer.ai. And if you're interested in getting involved in contributing using the library and whatnot, join the Discord. And if you're looking for cutting edge RL tutorials, anything in between, got a blog right here, all the latest stuff. And if you want even more RL content, you can follow my X. There's some articles here you can't find anywhere else, as well as a lot of RL posts, pretty much all RL. So thank you. And I don't know, might be back later tonight.